Hello everyone, welcome to the video lecture series of Internet of Things. In today's lecture, we are going to discuss physical design of IoT. I am Professor Swati Suresh Pawar. Before starting with today's lecture content, let us revise the contents of the previous lecture. In previous lecture, we have studied course structure of IoT, course content of IoT, course objectives of IoT, course outcomes of IoT, introduction to IoT, its definition and characteristics of IoT, IoT architecture. Now let us discuss physical design of IoT. Physical design of IoT focuses on how the IoT devices are built internally and how they communicate with each other. Things of IoT or IoT devices. Things in IoT refers to an IoT devices with a unique identity that has a capability of sensing, monitoring and actuating. IoT devices can send and receive data directly or indirectly and also has ability to process it to information. This processing can be done locally, remotely, using a centralized server or can use a cloud-based application platform for the same. IoT devices can process the data as per its memory, processor, speed, communication, etc. If processing requires higher specification of IoT infrastructure, can provide the same. IoT devices can pull together data from attached or onboard sensor, for example, IR sensor, temperature, humidity sensors, etc. and can process data locally or can forward the data to higher powered devices or cloud-based application. IoT devices and actuators can be connected together so that IoT devices can communicate with other physical entities, may be IoT based or non-IoT based system. For example, a relay connection to a small electric circuit in the house can control the appliances like light, fan, AC, etc. over the internet. There are various types of IoT devices available like sensor, LED lights, smart watches, wearable sensor, automobile parts, etc. An IoT device generally has a processing power, sensing ability, some storage capability, and some methods to connect external peripherals. The core processing power is provided by Central Processing Unit, that is CPU, generally working on maximum frequency of 1 to 1.5 GHz. Along with the CPU, additional graphical processing unit, that is GPU, can also be attached as per application requirement. Figure shows the general IoT devices and its contents. IoT-based applications uses embedded devices that uses flash type of memory, embedded multimedia memory cards, that is eMMC, secondary storage, NAND NOR type of memory is given to IoT devices. IoT-based devices need to communicate and interact with external devices, may be of same type or different type. For this, such devices provides connectivity such as input-output interface with general purpose input-output, that is GPIO, for connection of sensor, actuators, etc. Universal asynchronous receiver, transmitter, that is UART, for asynchronous serial communication to devices like GPS, Bluetooth, etc. IoT protocol. IoT devices communicate with each other and central node seamlessly throughout the internet network. Figure shows the IoT protocol in different layers. IoT devices communicate with each other and central node seamlessly throughout the internet network. For this communication to happen smoothly, various protocols are available in various layers of Internet Protocol suite. Some of the well-known protocols used by IoT-based application in various layers like link layer, network layer, transport layer, and application layer. First, the link layer. Link layer manages physical level of data communication in the network, for example, communication over a copper wire, twisted pair cable, radio waves or coaxial cable, etc. Link layer protocol manages communication between devices and hosts to which devices are connected. Link layer protocols communicate locally between host and devices over the link layer where connectivity is available via cables or radio wave, etc. 802.3 Ethernet. IEEE 802.3 Ethernet contains various wired Ethernet-based connection mediums. The shared medium in Ethernet can be performed using twisted pair cable, coaxial cable, or optic fiber. Data sent by source can be received by all the connected devices based on its capabilities. Data rate of 10 Mbps to 40 Gbps and more can be achieved using these standards. Following table shows the 802.3 protocol specification. Table shows the 802.3 protocol specification. Protocol standard 802.3. Protocol used is 10BASE5. For 802.3i, 10BASET protocol is used. For protocol standard 802.3j, protocol used is 10BASEF. For protocol standard 802.3AE, protocol used is 10 gigabytes per second over the fiber network. Now 802.11 Wi-Fi. IEEE 802.11 contains various wireless local area network based connection medium, that is WLAN. Data rate of 1 Mbps to 6.75 Gbps can be achieved using these standards. Following table shows 802.11 protocol specification. Table shows the protocol specifications of 802.11 Wi-Fi. Protocol standard 802.11a having 5 GHz of band. Protocol 802.11g and 802.11g is having 2.4 GHz band. Protocol 802.11n is having 2.4 to 5 GHz of band. Protocol 802.11ac having 5 GHz of band. Protocol 802.11ad is having 60 GHz of the band. Now 802.16 WiMAX. IEEE 802.16 contains various wireless broadband connection medium with extensive use of link layer, that is WiMAX. WiMAX operates similar to the Wi-Fi but has higher speed, larger distance range and greater number of users. Data rate of 1.5 Mbps to 1 GB per second can be achieved using these standards. WiMAX also achieves 100 megabits per second for mobile, that is for moving system, and 1 GB per second for fixed star, that is larger compared to the Wi-Fi. Now 802.15.4 LRWPAN. IEEE 802.15.4 contains various low-rate wireless personal area network, that is LRWPAN. Data rate of 40 kbps to 250K can be achieved using LRWPAN standards. LRWPAN are used for devices with limited or low power and provides low speed and low cost communication which consumes less power. 2G, 3G and 4G mobile communication. 2G, 3G, 4G standards provides communication over a cellular network level. Second generation, that is 2G, include GSM and CDMA. Third generation, that is 3G, uses UMTS and CDMA 1000, while currently famous 4G uses LTE. Data rate of 9.6 kbps for 2G devices and up to 100 Mbps for 4G devices can be achieved using these standards. Now network or internet layer. Network layer handles sending and receiving the message packets over a network from source to destination. This layer handles addressing and routing of packets over the network. Host addressing scheme is managed by IP addresses. IPv4 Internet Protocol version 4 is the most used addresses scheme used for unique identification of the devices over network. IPv4 has 32-bit header length which provides 2 raised to 32 addresses distributed in the classes A to E. IPv4 is a connectionless protocol which doesn't guarantee packet delivery. Now IPv6. Internet Protocol version 6 is the successor of IPv4. IPv6 has 128-bit header length which provides 2 raised to 128 addresses which are far more than the IPv4 in comparison. IPv6 provides location system and identification for computer in network. IPv4 and IPv6 are not interoperable by default, but some development in this process where direct communication between the IPv4 and IPv6 is possible via middle level logic. Now 6LoWPAN. IPv6 over low power personal area network is designed for lower power devices where communication overhead should be less. Devices with low processing and communication capabilities use this protocol in network layer. 6LoWPAN networks over frequency range of 2.4 GHz and has data transfer rate of 250 kbps. 6LoWPAN in network layer and 802.15.4 in link layer works together and describes compression mechanism for IPv6 packets for communication in LRWPAN. Third is transport layer. Transport layer manages end-to-end communication irrespective of the underlying network. Transport layer defines communication to be connection-oriented or connectionless. Added features such as error correction, segmentation, congestion control and flow control are also managed by transport layer. TCP, Transmission Control Protocol, that is TCP, is a connection-oriented protocol used by web browsers, email programs for file transfer, etc. TCP ensures that the sent packets are received to the destination if not resending of packet is also provided. TCP provides error detection, meaning duplicate packets can be removed. Flow control manages sending data rate is not too higher than the receiver's processing capacity. Congestion control avoids jamming of packets in the TCP-based communication. Now UDP. User Datagram Protocol is connectionless protocol which doesn't require initial connection establishment phase. UDP is generally used for faster communication where connection establishment phase takes time. UDP doesn't support retransmission of data or removal of duplicate packets. It doesn't even guarantee packet delivery. Application layer. Application layer protocol manages how the lower level protocols and application interface will be communicating for sending and receiving of data packets. Applications usually use files as a transfer mechanism. Such files are encoded by the application layer protocols and compressed by the transport layer protocol for communication in the network. Application addressing or identification is done by unique port number which are used for process-to-process communication. Some well-known application layer protocol in short are HTTP, that is Hypertext Transfer Protocol, is the base for WWW, that is World Wide Web. HTTP protocol has commands which are used for data communication by applications. Then get, put, post, delete, etc. are some of the such commands. HTTP is a stateless protocol and uses request response communication model. Universal Resource Identifiers, that is URI, are used for maintaining HTTP resources generally over a server. Clients uses this URI to access the HTTP resources. COAP, Constraint Application Protocol, that is COAP, used for machine to machine, that is M2M communication, where the applications are meant for small embedded devices, control environment and constraint network. Similar to HTTP, COAP is also a web transfer protocol and follows request response model. COAP uses client-server communication using UDP based communication. Similar to HTTP, COAP also provides commands like get, put, post, delete, etc. and both are simply interoperable. WebSocket. WebSocket is a TCP type of communication protocol which establishes a connection before transferring any data packets. Once connection is made between client and server, same connection is used for stream transfer until closed by the client explicitly. Then MQTT, Message Queue Telemetry Transport, uses publish-subscribe model of communication. In MQTT client-server communication, client connects to the server and publishes message to topic available on the server. Intermediate broker message. These messages from client and forward it to the consumers subscribe to the topic. MQTT is useful in applications and devices where resources, that is processing and memory, are limited and has low bandwidth. Then XMPP. Extensible is a messaging and presence protocol, is used for real-time communication and also when XML data needs to be streamed in a network. XMPP allows transmitting XML-based data in small chunks throughout the network devices in the real-time manner. Client to server and server to server communication is possible using XMPP. XMPP is a decentralized protocol which provides high-powered application support such as voice, video calls, multi-party chat, gaming and messaging, etc. DDS, Data Distribution Service, provides data-centric device-to-device or machine-to-machine communication. DDS uses publish-subscribe model of communication in which publishers, that is device that guarantees data, creates topic to which consumers, that is device that want to use this data, can subscribe. DDS has configurable reliability and also provides the quality of service. AMQP, Advanced Message Queuing Protocol, is an open application layer protocol mostly used for business messaging. AMQP uses point-to-point and publish-subscribe model of communication for routing and queuing of data. An intermediate AMQP broker messages and its flow through the network. It receives messages from publisher and routes it to the subscribed consumer. This is done using queuing technique. Published messages are copied into the queues. Message can either be delivered by the brokers or consumer can pull them from message queues. Summary of the lecture. In today's lecture, we have discussed physical design of IoT. Thank you.